Since we've been discussing linear functions and arithmetic sequences this entire unit, we're going to go a little bit deeper into linear graphs and learn some key characteristics and how to analyze them. So there's a lot of vocabulary up front. A lot of this will make more sense when we get into the actual problem, so I'll kind of re-explain. We've already talked about domain and range. Remember that as long as it is continuous, which for these, they will be continuous, they're connected, we're going to use interval notation. We could use set notation, but to me, it's a little bit easier just to use interval notation. For domain, we're looking at x, so we're going to look at, does it go left forever, does it go right forever? For range, we're looking at y's, and that's does it go down forever, and does it go up forever? End behavior describes how the ends of the function are behaving. Now, keep in mind that if you're just talking about a line, lines do not end, but what you're saying is, you know, is it going up, down, left, right? And so end behavior for linear functions is going to look the same. The left end, x, is going to be approaching negative infinity, and that's why you see right here it says x, and that arrow means approaching negative infinity. That's because if x is approaching negative infinity, it's going left. And then what you're going to need to decide is what is the f of x or the y doing? And your options are up or down. So if it's going up, you'll put infinity. If it's going down, you're going to put negative infinity. That will change as the type of functions we explore change, but for linear functions, it's pretty basic. It's going to go up or it's going to go down. So up is infinity and down is negative infinity. On the right end, because it's going right, if a function approaches the right forever, that is positive infinity. So it says x is approaching positive infinity. And the same thing, your line is either going to go up or it's going to go down. It will do the opposite of what it does on the left end, because lines, one end goes up, one end goes down, unless it's vertical or horizontal, but we're not going to be analyzing vertical and horizontal lines. And again, I'll explain that in a little bit more detail when you have a physical graph to look at. Some more vocabulary is increase, decrease, positive, and negative. And these two are probably the hardest. They often get confused. The good thing is on linear, increase and decrease is pretty easy. Increase means to go up, decrease means to go down. We always look left to right. So if you're looking from left to right, a line will go up or it will go down. So it will do one or the other. It will not do both. So one of those intervals is going to be negative infinity to positive infinity because it's going to be going left forever and right forever. Positive and negative have to do whether your graph is above or below the x-axis. And for positive, you're looking at positive y values. Well, positive y values fall in the first and also in the second quadrant, and that's why it's positive when it is above the x-axis. It is negative when it's below the y-axis. You're also going to go left to right on this. Lines will have both a positive, an interval of positive and negative. Unless they were completely above or completely below, but we're not going to be analyzing horizontal lines. So you'll start at the left, which is negative infinity, and you'll end at the right, which is positive infinity. You will use, again, x coordinates as you do increase, decrease, positive, and negative. All right, so let's look at an example. And again, I think that'll make it easier. It'll take a few examples usually for it to click. So don't be frustrated if you're confused after one example. It is completely normal. So we're going to start by writing the function. Okay, that part should be hopefully the easiest part. In order to write the function, we're going to use slope-intercept form. So we're going to do y equals mx plus b. So that means we need to know the slope and we need to know the y-intercept. All right, the y-intercept is typically the easiest. If you look at the graph, you can see it crosses the y-axis at 0, -6. So that means, well, we can go ahead and write this down. Y-intercept is 0, -6. That means the b is -6. So we know at the end it's going to be -6. to find the slope, we need to find another concrete point on this line. So you can use, it looks like 3, 0. That's the x-intercept, which we could go ahead and write. And then you're going to count rise over run. You go up 6 and you go right 3. So your slope is 6 over 3, which is equivalent to 2. So your slope is 2. Now, you may have not used those 2 points. You could have used 2 other points, like right here and right here. And if you count, you're still going to go up 2 and over 1. I like to add all of the points I can on the graph, just because then to me it's a little bit easier to see what that slope is. So if I look at that, I can see I'm going up 2 over 1, up 2 over 1. So that slope is 2. For domain, you're looking at x. So for x, ask yourself, does it go left forever? And yes, this line does. You can see the left arrow here. Now it's also going down, but down is talking about y. We're focusing only on x. This graph is going left forever, so we will write negative infinity. Does it go right forever? Yes, that arrow points to the right forever, so that means it is going to positive infinity. So your domain is negative infinity to positive infinity, which is the same thing as all real numbers. For the range, since range is y, you're going to ask yourself, does it go down forever? It clearly has a down arrow, so the answer to that is yes, so that's negative infinity. And then does it go up forever? It does, so it goes up to positive infinity. Most lines go left forever and right forever, so most lines will have a domain of negative infinity to infinity. Most lines go down forever and up forever, so most lines will have a range of negative infinity to infinity. Again, this will change as we start to look at specific examples like we've done in previous problems, and as we change the function to not be linear anymore. All right, next up is end behaviors. So for the end behaviors, I want you to focus solely on the arrows. I'm going to draw those arrows. Even though they're not there, they weren't drawn, they should be there. All right, and I always go left arrow and right arrow. So this one right here is a left arrow. Because it's going left, that is why this says x is approaching negative infinity. X approaching negative infinity means left. But not only is it going left, it is also pointing down. So because it's pointing down, that means y, or f of x, is approaching negative infinity. Now let's look at the right side. Okay, that arrow is pointing right. That's why this says x is approaching infinity, because if it's going to the right, x will approach infinity. Not only is it pointing right, it is pointing up. So because it is pointing up, that means y, or f of x, is going to positive infinity. These two end behaviors for a line should be opposites. Okay, because a line will go up and down. So one end goes down, one end goes up, unless it's horizontal. And again, you're not going to analyze a horizontal line. All right, next up is increase. So one of the things that students struggle with is the definition of increase, decrease, positive, and negative. They often confuse them. So something that I have found very helpful for students is on the left side, label it negative infinity. And on the right arrow, label it positive infinity. When you do increase and decrease, and when you do positive and negative, you are going to start at negative infinity and go to positive infinity. I usually take my pencil or my finger and I trace it. And I'm going to use colors here so you can see it. So I am going to start at negative infinity right here. Let me use a different color. And I am going to trace to infinity. And as I'm doing that, I need to think about, is my pen going up or is it going down? Well, it's going up. It will never go down as long as I go from negative infinity to infinity. So since it's going up, it is increasing, and it will always increase, starting at negative infinity, ending at positive infinity. And because it will never go down, then you would write none for decrease. Lines do one or the other. They cannot go up and go down. Okay, so make sure that one of them says none. For positive and negative, we don't care if it's going up or down. What we care about is it above or below that x-axis. So I'm going to kind of make this x-axis stand out. Okay, I'm looking above or below that line. If you want to think about it as water, and if you're above the water or below the water, that's fine. Just like increase and decrease, we are going to start at negative infinity. So if I put my pen at negative infinity and start tracing, I am below the x-axis, and I will continue to be below that x-axis until I hit the x-axis at 3. So that green piece right there is negative because it is below the x-axis. If I were to write all of the points out, all of them would have a negative y-coordinate. Okay, so our negative interval started at negative infinity because that's where we always start, and it stopped being below at 3. And we're going to use a parenthesis because when we hit 3, that's 3, 0, and 0 is not positive or negative. But I need to continue going because I have to end at infinity. So if I pick up at 3 and I keep going, all right, I've got to make my way to infinity, all right? The rest of that line will be above the x-axis. So because it's above, it is positive, and it will be positive from 3 to infinity. Intervals of positive and negative will use that x-intercept. So you'll notice the x-intercept we said was 3, and you can see that 3 in both the positive and the negative interval. I know that was a lot of information to throw out there, so we're going to practice. For number 2, we're looking at the function f of x equals negative 2/3 x minus 4. Remember that that is in slope-intercept form, so our slope is negative 2/3, and then our negative 4 represents the y-intercept, which is, you can see on the graph. So I'm going to go ahead and fill in that y-intercept. And remember that it is a point at 0, 4, so I'm going to write it as a point, sorry, 0, negative 4. Y-intercepts always have an x-coordinate of 0. The x-intercept is where it crosses the x-axis, and that is at negative 6, 0. X-intercepts should have a y-coordinate of 0. For our domain, we are going to look at, does it go left forever and does it go right forever? So if we look at the arrows, it is going left forever, which means x approaches negative infinity, and it does go right forever, which means x approaches positive infinity. Again, that's all real numbers. That means x can be anything, anywhere on this graph, because this line goes on forever. You're not, you physically can only see what's right in front of you, but you have to also think about if it continues, what will happen to it. The range is y, so we're looking at if it goes down forever and up forever. It does go down forever. That arrow on the right side is also pointing down, so that means it goes to negative infinity. And then the arrow on the left is also pointing up, so that means it goes to positive infinity. Again, like I said in the last slide, most lines are going to have this domain and range. The only time that changes is if it's vertical, if it's horizontal, or if you're looking specifically in the context of a problem. And then we will look and explore other functions like quadratics and exponentials, and their domain and range may change. For end behaviors, we're focusing on the ends. Again, this doesn't really end, but we're looking at the arrows. So I always do left first, so that would be this arrow right here. It is pointing left and up. Left means that x is approaching negative infinity, which I already gave you. Up means that the f of x is approaching positive infinity. Now let's look at the right end. That right arrow is pointing right and down. Because it's pointing right, that means x is approaching infinity. That was already given to you. Because it's going down, that means f of x is approaching negative infinity. Right. Now we're going to get into increase, decrease, positive, and negative. All of these go from left to right. Label the left end negative infinity and the right end positive infinity. And what throws a lot of students off is they look at that right end and they see down and not right. We are focusing on left to right when we're writing the intervals. So increase means to go up, decrease means to go down. Put your pencil at negative infinity, start tracing. Is it going up or is it going down? It is going down and it will always go down. That means this is decreasing from negative infinity to positive infinity. It will never go up from left to right, so it has no increase. If you look at the slope of the line, it is negative. When the slope is negative, it will decrease. When the slope is positive, it will increase. All right, next we're looking at positive and negative. Positive and negative have to do with above or below the x-axis. So here is our x-axis right here. Are we above or below? That's what we want to know. I don't care if it's going up. I don't care if it's going down. All I care about is above or below. And we are going to start at negative infinity. So that's on that left side. Currently at negative infinity, we are above the x-axis. This whole piece will be above the x-axis until it hits the x-axis at the intercept, which is -6. So because it's above, it is positive. And it is positive from negative infinity because that's where we started until we hit the x-intercept at -6. Then if we keep going, right, picking back up at -6, we continue to trace until we end at infinity. All of this is below the x-axis, and because it's below, it is negative. We started our pencil at -6. We ended at infinity. Last one of these that we're going to look at is number 3. Its equation is f of x equals -3x plus 3. That means it has a slope of -3. It's going down 3 and over 1. It has a y-intercept at 0, 3. So why don't we go ahead and put that y-intercept at 0, 3. Remember, y-intercepts always have x equal to 0. You can see it right there on the graph. You can also see it right there in the equation. The x-intercept is where it crosses the x-axis. You do not see that in the equation, but you can see that on the graph. That is 1, 0. X-intercepts are always an x value and then 0 for y. For our domain, let's add our arrows. Domain, does it go left forever? Right? If you look at that left arrow, it is pointing left, so it does go left forever. So that means it's going to go to negative infinity. On the right side, it's got an arrow. I know you probably see it as going down, and it is going down, but it is also going right, so it's going to go right forever, so that's to infinity. For the range, we're going to look at the bottom. Okay, this goes down forever, so that means our y value is going from negative infinity, and if we look at the top, it's going up, so that's going to positive infinity. Both our domain and range go on forever. Everything is included, all real numbers. Now if we look at our end behavior, we're looking back at those arrows. So we'll start with the one on the left, which I've already circled. It not only goes left, but it goes up. Because it goes left, that means x is approaching negative infinity, which I already gave you. Because it's going up, that means f of x, or y, is going to infinity. On the right end, it is going right and down. Because it's going right, we say that x approaches infinity, which was already given to you. Because it goes down, that means f of x approaches negative infinity. Remember that on a line, your f of x's should do opposite things because lines either go, one end goes up, one end goes down. All right, before we get into increase, decrease, positive, and negative, I am going to go ahead and label that left end negative infinity and that right end positive infinity. I'm doing that because I'm talking about left and right. Okay, so the left end is labeled negative infinity because it's left. I don't care that it's going up, I care that it's going left. And that right end is labeled infinity. Even though it's going down, it's labeled infinity because it's going right. Really, that's tricky for a lot of students to understand. Always start at negative infinity, always end at positive infinity. We'll start with increase and decrease. We're looking at, is it going up or going down? Put your pencil at negative infinity, start tracing in the direction of infinity. Is your pencil going up or is it going down? It is going down, and it will go down forever. That means it is decreasing, starting at negative infinity, because that's where we put our pencil when we started, and ending at positive infinity, because that's where we ended. It will never increase, so we'll write none. Remember that if your slope is negative, your graph should be decreasing. All right. Positive means that it's above the x-axis, that's up here. Negative means that it's below the x-axis, which is down here. We're going to start at negative infinity. We're going to end at positive infinity. We'll have to take a break when it is on the x-axis. So I'm going to start at negative infinity and I'm going to start tracing. Right now, it is above the x-axis. It doesn't matter that it's going down. It is above the x-axis until it hits the x-axis. That whole blue section is positive because it's above the x-axis. We started at negative infinity, and when we hit the x-axis, that was at not negative 1, that's a positive 1. That's our x-intercept. All right, and we're going to keep going. We're going to start back at 1, and we're going to go until we hit infinity. So all that purple piece, that is all below the x-axis, so that makes it negative. Where is it negative? Well, we started at 1, and we continued until we hit infinity. So it is negative from 1 to infinity. Positive and negative will use that x-intercept. So that's why you see the 1s in the positive and negative intervals. All right, the last two problems, I'm giving you a description and you are going to draw the graph. Some of these must be done in an exact way, and some of them you have a little bit of flexibility. It just depends on how specific the description is. So for number 4, it says create the graph of a linear function that has an intercept at 0, -2, and is positive from negative infinity to -3. All right, so the first thing I'm going to do is graph that intercept at 0, -2. Now, it doesn't say x-intercept or y-intercept. You have to know how to graph. 0, -2 means you do not go left or right and you go down 2. So that is a y-intercept. Anytime that x is 0, that's going to be a y-intercept. All right, so right here. Then you need to know what positive means. Positive means above the x-axis. And that's from negative infinity, which is the left, until -3. So -3, when you have positive and negative, that number in there is your x-intercept. So I'm going to put an x-intercept at -3. And then as it goes to the left, I need it to be above the x-axis. Above the x-axis, and I need to connect it to that y-intercept. You want to make sure that you do it a line. Mine kind of looks bent. It's not supposed to look bent. It is a line going through -3, 0, and 0, -2. This one must look like this. There is no other way to draw this one. So again, you can see that from -infinity to -3, it is above the x-axis. That's what makes it positive, and then it's got that y-intercept at 0, -2. All right, number 5, create a linear function that is increasing. So increasing means that it's going up, so we got to make sure it's going up. It'll look like that. And it has to have an intercept at 5, 0. Again, this does not specify if that's the x-intercept or the y-intercept. However, when graphing, to graph 5, 0, that means go right 5 and up or down none. So that is an x-intercept. When that y-coordinate is 0, it's an x-intercept. So we've got the intercept, and now we just need to make it increase. So you can draw that line at whatever steepness you want as long as it's going up. So I'm just going to go, I'm going to erase my y-intercept for some reason. Sorry, their x-intercept. Okay, but you could do it a little bit flatter. You could go like that. You could do it a little bit steeper. What you can't do is you can't make it go down because it has to be increasing. So just make sure you don't decrease. Any of those 3 lines, and a lot more lines would be acceptable. Just make sure that if you go from left to right, if you start the left arrow and go to the right arrow, that you are going up.